Hi, I'm Jeff King. Today I just want to explain a little bit about how I use a CDN to make your resources load faster for your clients. So the first thing is a CDN is a content delivery network, and really it's a bunch of servers around the world that you can store data on. So if you have a server in the US, but you have clients, say, in India, there is going to be like a fair amount of latency to deliver the content from your servers all the way to your users in India. So what we do is we actually do edge caching. So that'll be a set of servers that you have access to store your data on. And then these will actually be what feed the users in India. And typically what happens is if on the first request this server doesn't have that piece of data yet, it will go and retrieve it from your set of servers. So that first call still might have that latency, but all subsequent will then have the very reduced latency. So this is really great for getting your global traffic to have fast response times. So that's just kind of the overview of what a CDN is. Now what I like to do when I'm developing a website or web application, or even API for that matter, is I really look at how I can leverage the CDN. There's two huge benefits to it. So on a typical web application, you will have to run some sort of web server. Now this can be like platform as a service web server, where you don't have to manage too much of it, which is great. But at the same time, if you put your resources here, let's talk mostly about a JPEG today. So if you put your images on your server, when a user wants that image, it will have to request it from your server. Seems pretty straightforward. So that server obviously has like a maximum number of requests that it can handle. So I don't know, let's just say like you can handle 1,000 requests per second. And you have numerous static resources typically on your site. So you can have images and CSS and et cetera, right? So in order to facilitate these being served, you actually have to potentially scale out the number of instances that you're going to run, which means that's going to cost you more money. And there's not really much point of you running this kind of static content off of your own servers. So what I like to do is you'll have your web server, and then you'll start with CDNs sitting alongside your web server. So I'm going to speak a little bit to what Microsoft Azure has to offer, but this is kind of how I see the picture. So if you look at like, we're going to just stick to talking about a JPEG image. So let's just say this is like a resource, like, you know, in the header of your site or your logo or something like that, right? What I like to do is actually have three options available for this kind of asset. So you can keep it on your web server. So then your designers can just call it from the web server as needed. Pretty straightforward there. You'd have like your domain name, www.domainname.com/.jpg, right? Whatever that URL is. Now on Azure we have two other ways to serve this content, which is great. So this is just straight blob storage. And blob just stores for binary large object. So what I like to do is actually store all those static files in blob storage. And that could be like, you could have content.yourdomainname.com. And then this would give you another way to call that static asset. Now the big thing here that starts really helping you is the servers for blob are all hosted in this case by Microsoft. And so it becomes Microsoft's problem to actually scale up the number of servers there, which they can do very easily for blob storage. And so that starts to kind of detract from potentially the cost of your web servers. Now, of course, there's a cost here in terms of bandwidth, and data storage, but blob storage is like the cheapest kind of storage that you can have in Azure, or the type of storage that's really cheap on other cloud providers as well. Now, secondly, this is where the CDN comes in, because the way that the Azure CDN works is it can sit on top of blob storage. So then you can create something like cdn.yourdomainname.com and again serve out that asset. So now, by doing this, you give your designers or developers a choice as to where they want to pull the assets. So there's a lot of reasons why you would choose any one of these. If you don't care about like caching, so something like a logo, then this is a really great way to do it. I would recommend pushing as many assets to the CDN as possible. Secondly, if you're going to be updating the asset more frequently, then you might want to deliver it just straight off of blob storage. And then the only reason really to fall back to your web server for these static kind of files is if you're worried about like cores or JavaScript files and things like that. Typically then I would fall back to using the web server for that type of static file. Otherwise I would try and push as much as I can to the CDN to give your users the best experience possible. The other thing that I do with CDN a lot is actually, so this is your www.domainname.com, and this is your content in your CDNs. This is your web server, this is your blob, and then this is your CDN of that blob, okay? Is actually to put another worker role in the middle, and this can actually pull data from a database or a data store, and actually would store .json files. So let's say like product. So we have like a product.json file being generated like every, I don't know, 2 minutes, depending on how often your product data gets updated. Or else it could be like on kind of a push, like you add a new product to a queue and then it would deliver that. And you can actually then almost treat these like APIs. You could have like content.domainname.com/API/product. And while you don't get the, like, when you wouldn't get like parameter query strings, that's not really available to you, but you would be able to serve out these static JSON files. And again, the big thing here is it gets it off of your servers and puts it onto whatever your like binary storage provider is. And again, if it's data that doesn't change frequently, like, you know, weekly, monthly, you can set the headers obviously, but you could put that within the CDN. So if you have a product list that's relatively static, like changes once a week, you could even have your users then call for that JSON off of your CDN URL. And so this is kind of how I see delivering fairly static content in a cloud environment. Remember just to try and remove your web servers from doing the actual heavy lifting.
I'm Brian Lewis, and I'm here with Janelle Carruthers. We're both IT evangelists with Microsoft, working in the Developer Evangelism organization, and today we're going to talk about Azure Site Recovery. Janelle, welcome.
Thanks, Brian. Azure Site Recovery is this totally cool way of getting your on-prem stuff into the cloud, so I'm excited to talk about it today.
Excellent. Yeah, Azure Site Recovery is our crown jewel of backup. It's probably the more expensive offering we have in backup, but it also has a very low recovery point objective and recovery time objective. So the amount of data loss is near zero, and the time to restore is as fast as you go turn it on, really.
But I'm in California, and earthquakes are always a big deal. So the idea of being able to quickly recover something from on-prem when that on-prem might not even exist anymore, being able to spin that up in the cloud pretty quickly, it would be, you know, a lifesaver or a business saver.
All right. Can we take a look at the little diagram that we have of how Azure Site Recovery works before we move on?
Yeah, great. Talk us through that.
So as you can see, Azure Site Recovery here, there's actually several options we have where we will take machines, whether they're VMs from on premises, they could be Hyper-V, they could be VMware, and we'll take those and move that target up to Azure Storage, and we move the whole machine. At the same time we do that, we switch it out. So if it's Hyper-V and it's Gen 2 VMs run VHDX, we convert those to VHDs. If it's VMware, on top of a VMDK file, we take that and we convert it to a VHD file, and we do all the conversions that need to happen to make it run well in Azure. As well as if it's on local hardware, physical machines, we're going to take that and convert it to run in there as well. So it's really nice from that sense. You can even use it to migrate AWS, Azure, or Amazon VMs to migrate those into Azure. We can even migrate from one Azure region to another Azure region with little downtime using ASR. So ASR is kind of great for multiple scenarios there. And the way we price it is interesting because ASR is free for the first 31 days. So why is that?
So you can use it like as your Ginsu knife for migration, because you can just do that in the first 31 days and then not have to pay for the recovery process. Just use it to sort of lift and shift.
Yeah, it's our migration tool, definitely. And so if you use it as a migration tool, no charge at all for it. If you're going to continue to use it after 31 days and use it as your backup tool, then we have ASR pricing that applies. Best way to see what the latest pricing is really to check the Azure website.
That changes a lot.
Yeah, so how it works is pretty interesting. We install an agent on the machine itself as a file system driver, and then it takes that data and puts it to a process server. That process server then encrypts it and compresses it and ships it up to a target server up in Azure. That Azure server as well as the config server are up there, and that saves it down to a VHD file up there that's then ready to be turned on.
So it sounds like that process server is actually going to be doing all those little conversion tidbits and things like that that might be required from your source, and then just getting that up into the cloud. It's sort of held onto the master target server until it's really needed.
Yep, that's exactly it. And the reason it's a separate server as opposed to doing that stuff on the VMs you're copying data off of is because that way we are very light on those source servers, and we won't affect performance in any great amount because it's a very lightweight file system driver that just takes the file changes and sends them over to the process server. The process server does all the work of encrypting and compressing and making it small to transfer across the network.
That's pretty cool.
Yeah. So that's how it works. And I believe you are going to show us a demo of how to set this up, make it work.
I do have a demo of this, and when we switch over to the demo, but just a little quick background, it is Azure. It's that Azure to Azure, that third scenario. So, but doing Azure to Azure actually looks like physical to Azure. So it's pretty interesting. So we'll flip over to that demo.
In this demo, I'm going to give you a quick tour of Azure Site Recovery. As of this recording, the site recovery features are only accessible using the classic Azure website. But in the future, you'll be able to access them using the new portal. You can find Site Recovery under Recovery Services. On the Quick Start page, you can see the variety of support options you can take advantage of and the necessary steps to be successful. Depending on your source environment, different technologies and components are used to recover resources in the cloud. For this example, I'm going to show you the physical server to Azure scenario. However, I'm going to simulate my physical infrastructure using Azure. This isn't supported at this time, but it saves me from having to stack up server hardware in my kitchen for demos. In this recovery type, you can see that I'll need to deploy a configuration server, a master target server, a process server. I'll also need to install an agent on my machines. I'm not using VMware, so I won't need to install a vCenter server. So you understand what I'm going to be protecting. Let's take a quick look at my virtual networks that I've created for my on-prem servers. You can see I have a virtual network with a private address space and two servers, ABC and DEF. You can also see the process server, which is a component of the recovery services that collects data from the individual agents and sends that data to Azure. You'll need to install the process server on your local network. There are a few other important networks involved. My fake on-prem network is located in the West US. For the site recovery service itself, I have that located on a network in the central US. I also have a failover network set up in the same region as the site recovery network, also in central. This would be the destination network for my 2 servers when failed over. Let's first take a look at the servers that are part of this recovery service. In this case, I have a configuration server, and it's communicating with the process server and the master target server. The master target server is the server that hosts the copies of the disks replicated from my source environment. Under protected items, you can see I have one protection group which contains my 2 source servers. Here you can see the status of the protection and the estimated recovery point objective based on the replication. When I go deeper into the properties of each server, I can see how many disks are protected, how many consistency points are available, and stats for how much changed data is sent from the server. Under Configure, I can adjust the size of the destination VM in Azure, and I can also select which network I want the server to fail over to. In this case, I want my server to fail over to my failover network, but I could also use the same network as my configuration and master target servers. The final configuration needed for this scenario is a recovery plan. It's worth noting that the name of your recovery plan will become the name of the cloud service during failover. So you might want to be a little more creative than my failover. I'm going to select both of my servers to be part of this plan, but you can have multiple plans if necessary. Now, within each plan, you can group the servers to ensure that any necessary dependencies are addressed by having the servers recover in a specific order. By default, all of the servers end up in one group, so you can see these 2 servers underneath group 1. However, I can go ahead and add group 2 and move a server to group 2. So I'll have server DEF recover after server ABC. Once the recovery plan is created and configured, it's ready when you need it. Now, if I want to take advantage of this recovery plan and do a failover, I simply select failover. I'm going to go with the latest recovery point in time. It's going to fail over from my configuration server to Microsoft Azure, and I'm going to go ahead and click Go. At any time, I can go check on the status of my job by hitting the Jobs tab. I can check on the details of my failover by drilling down into it, where I can see the different steps and their current state. Okay, we're back after the completion of our failover. You can see that it's successfully completed with green check marks all the way down the bar there. So let's take a look over at the networks again to see that our servers ended up where they are expected to be. My original fake on-prem network with my server ABC, DEF, and the process server is essentially unchanged. The recovery network where the configuration server and master target server work are also the same, but the failover network that was empty before we started now has copies of server ABC and DEF that have been recovered there successfully. So hopefully this demo has given you a quick little idea of some of the power of Azure Site Recovery Services. Thanks for watching.
Great demo. Thanks, Janelle. That was awesome to see. So in summary, let's take a look at the different options we have. We saw what you just showed us was from Azure Site to Azure Site.
Well, yeah. I mean, it was actually sort of more like number 4 because I was kind of faking the physical to kind of show those other components, the process server and the configuration server and things like that. But it happened to be physically from 2 Azure sites to each other. So, you know, a little bit of a hack back there, but definitely shows the value of the service.
Very cool. So the options we have, we can go from Hyper-V to Hyper-V.
Right.
We can go, even with SAN replication, we can do a management of that across and use Azure as the management tool to do an on-premise to on-premise environment, which we didn't talk about much, but that's using System Center.
Right.
And then we have the stuff that I'm really jazzed about, which is this conversion tool of changing Hyper-V to Microsoft Azure, or VMware or physical machines to Azure, and even doing Azure to Azure.
Right. I mean, with the true Azure to Azure, you probably don't really need the same process server, and the exact same kind of magic isn't happening. Each one of those options that you presented require different conversion things to happen or not happen. So they're all slightly different scenarios, but the end result is the same.
And I know the last time we looked at this, you and I were talking to the product group, and they had talked about making things even easier for us. And so at some point, they're going to take that that destination server that we go to and actually make that into a service so that we don't have to set that server up and
Right.
manage that.
Exactly.
And so this will continue to evolve and change and become easier to set up, which is exciting to me because it does take a little bit of work now to set this up.
Right. But it still takes less work to set something like this up than to have to, recover things in some of the traditional ways that we've done in the last 5-10 years.
Right. So Azure Site Recovery, this is our crown jewel.